Welcome to our Hibernian coffee talk. Today I have a really special guest. It's Suresh Nampuri. Suresh, nice to have you here today.
Lovely to be here. Absolutely, even if it's virtual.
Maybe you want to start to introduce yourself a little bit. What did you study? What were your first business experience? Something that we
Oh
can.
yes, okay. Let's see. That's rather an expansive question. Okay, so I am a researcher in string theory or quantum gravity, however you call it, in academia. That's my academic job. I work at a place called the Institute Superior Técnico, which is in Portugal, in Lisbon,
Mhm.
at the Department of Mathematics. So I'm officially a mathematician, if you wish. I also am the co-founder of a theatre company called Joy International Theatre, which does, well, it is supposed to formally do theatre, but these days it does all kinds of hybrid stuff, including teleplays, teleperformances, and we are slowly branching into virtual reality storytelling. But at heart, I think I've basically been always a storyteller. I like telling stories. If those stories involve atoms colliding and various permutations of atoms forming complex objects, then you call it physics. If they involve human beings colliding with various atomic behavioral patterns of human beings being modeled into a story, then you just call it theater. It's the same thing. At the end of the day, I
Mhm.
just tell stories, and that's what I've been doing for, I don't know, close to maybe 15 years by now, including my training. But for now, I've been traveling through various countries. I was in Munich, I was in Germany, France, South Africa, and now, well, I'm in Portugal right now.
Perfect. Thank you. So you told you're working with or inside the string theory. What fascinates you being a scientist?
About string theory? Okay, so what fascinates me about in science is basically gravity.
Hmm.
Gravity is one of these mysterious forces that just cannot be comprehended. It's one of the first forces that as a child you discover. Before you understand fridge magnets, before you understand electricity, before you understand anything else, and before you understand atom bombs, as a child, you learn from the bruises you pick up when you fall down that gravity exists. It's one of the first things you learn. Then you start studying electricity, you discover fridge magnets, you discover electric lights, and then you say, oh, there's a theory of electricity, there's a theory of magnetism. Then at some point somebody comes and tells you, oh, there was an atom bomb, and there's a theory of that, there's a theory of how
Hmm.
atomic forces work. And you can understand all of this by now very clearly in a model called the Standard Model. And yet, you cannot understand gravity. And part of the reason, which I think was really fascinating, was this very illusory nature of gravity. Gravity felt to me like a story in the following sense. Um, One way to understand gravity is to say it's a force of attraction between two massive particles. This everybody knows because you learn it in school, right? Well, yes, quite. But one could also think of it, and this was Einstein's famous intuition. If you have two people on the globe, on the Earth, for example, and they start at the equator on the lines of latitude, and they go on parallel tracks at the equator, they may think they are going on parallel tracks, but they'll converge at the North Pole. But because they're very small people, they don't know that they are living on a big sphere. They think they're living on a flat piece of land. So they think, oh, something has brought us together, although we were going on parallel paths. I don't know what it is. Maybe it's a force, maybe it's love, maybe it's attraction, it's something. Well, you can call it gravity if you feel like. Gravity is, in other words, a story that you tell yourself to explain the geometry of where you are. In other words, it's very funny. It's not like the other forces. That's really funny. Also, there is no protection against gravity. There are ways in which, if there's a magnet in the next room, I can place myself in an iron or steel cage and protect myself from the magnet. There are ways in which you can insulate yourself from electricity. You can wear rubber soles, for example. You cannot protect yourself from gravity because anything that has mass has gravity. So if there is something that's attracting you and you say, oh, I'm going to hold a shield, that shield is going to add to your mass. It is going to make you even more vulnerable. There is no counter effect to it. It is the ultimate irresistible story. And it was so illusory, it felt like a trick. I had to understand it. So one of the places where, if you want to analyze a trick, you have to go to a place where it's executed in extreme, namely in a black hole. So we understand all the things I said before in the first 5 minutes about the Standard Model, electricity, magnetism, this and that. Those have all been unified into a theory of quantum mechanics, which is the theory of how atoms work and how things work at the atomic level. Gravity works at large scales. It tells you how planets move and the sun moves and solar systems move. These are two different things. In a black hole, these two things come together, actually. You have the force of gravity and the force of quantum mechanics, the force that operates at large scale and the small scale. It's like having two different musical rhythms, and you need to understand how to dance to both of them at the same time. So quantum gravity, which is how you figure out how to merge these two, is a fantastic way to understand how to jam quantum mechanics and gravity together, essentially. So this fascinated me, which is why I basically went into the field. As it turns out, now this was a physics problem. It's electricity management thing, and I just started off by saying I'm a mathematician. So what am I doing with these things? Because it turns out that ultimately you study a lot of math. When you're doing physics, you study calculus, you study differentiation, integration, differential equations, you study all kinds of stuff. At the end of the day, it turns out when you're studying some of the most complicated objects in the universe, namely black holes, it turns out that the way black holes organize information, the way information is organized in black holes, is in terms of discrete numbers. 1, 2, 3, 4, 5, 6, 7. So you start off as a child by studying 1, 2, 3, 4, 5. Then you said, oh, let's look at real numbers, decimal points, 1.3, 2.5. Then you went on to imaginary numbers, irrational numbers, all kinds of numbers. And then eventually, when you study the most complex object in the universe, it turns out that the mathematics governing them is precisely the mathematics of discrete numbers like 1, 2, 3, 4. There is an elegant simplicity about it.
That sounds so fascinating.
It is. So that's what fascinates me about string theory and about gravity. That's how I end up essentially being more or less a mathematical physicist. Somebody who studies number theory as much as studies gravity. So that's it, in a very small condensed packet.
I feel you're really on fire when you're talking about science, about string theory. But I've heard now you're planning to found your first or your second own business. Maybe you want to tell us something about that.
Right. Actually, my second business, the one I'm planning to found, is kind of linked to the first one, the theatre company, funnily enough. So theatre is about telling stories, and it was wonderful to actually tell a lot of stories, and I've been telling a lot of stories in the meantime. But then I began to realize that one of the problems I faced when I was telling stories through theatre was I have a model of human behavior. I model human behavior. Then I say, if I put two people with these particular characteristics in the same room, my prediction is they will behave in this way. Then the curtain opens on premiere night, and you can check my model. If you feel that this model works, it's consistent, this is how people behave, then you say, oh, this is convincing, it's a good piece of theater, and it works. It's like an experiment on apples. If I have a model that says apples drop, and if I cut the branch and the apple drops, well, my model is correct. It's the same thing. Now, this is great, and this is how theater is conventionally practiced. What the problem is, in practice, I began to find something else happening. We work a lot in theater to understand aspects of human behavior in extreme situations sometimes, because it's drama, it's in dramatic situations, and to explore the nature of language itself. One of the things that we encounter is something called subtext, which is the things that are left unspoken between people. Like you meet somebody on a trip, and you become friends for the duration of the trip. This would happen in long cruises, for example, 100 years ago, I suspect. And then you say at the end of the cruise, you would exchange cards and numbers and say, let's keep in touch. And both of you know you're not going to do that somehow, although you say that line. You see a lot of things that are definitely false, but both of you know it's definite falsehood. It's subtext. And theater functions on this. So the question I had to ask myself was, subtext, of course, is the basis for how telenovelas and soap operas work, right? There's a lot of subtext there. So one of the things I wanted to understand was, suppose I take a learning program, an AI program, for example, and I ask it to analyze the best possible theater pieces I can think of, Shakespeare, Ibsen, Chekhov, the famous classics. I just ask it to learn from them, troll from them, and understand what it is that human beings are trying to say when they say these words, essentially, and to generate subtext. In other words, what this program is meant to do is to generate subtext from actual apparent text. It's like a child learning psychology, if you wish. So it's a learning algorithm. And the idea of this is, of course, eventually what we'll do is it will start generating its own scenarios for how human beings could deal with conflict resolution, for example, or with leadership problems, for example, or more importantly, with how to formulate ethically correct narratives. So one of the things that we have is we have people with enormous narrative talent. One of them might be, I don't know, Hitler, for example, who has got enormous narrative talent. He crafts this beautiful story of superiority, of racial superiority, and so on and so forth. It is very, very adrenaline charging, okay? And it can lead you to, interestingly, terrible decisions, obviously.
Mm-hmm.
It's the narrative that counts. It's the narrative that counts. Somehow, your definition of what it means to be an ethical human being can be subverted depending on the narrative you're looking at. So what I would like to understand is there a way, and something like Hitler, and more recently, I think with Trump, for example, we see that when these people take control of the narrative, it's very hard to dilute it afterwards. It's very hard to push back at that time because they're on fire. You cannot, it's like napalm. You can't even douse it with water. Question, is there a counter narrative that's possible for people to start believing in things? Now, to do a counter narrative, you have to have a machine that can look at all possible narratives and all possible human stories and understand which narratives can lead you to behave in an ethically correct sense. So this is a pattern recognition system. So one of the things I wanted to do, and this was in 2019, I was thinking about it, was to say that maybe I should, so I hooked up with a friend called Joao, who is got a PhD in behavioral economics, and a friend called Natalie, who actually does communications in Brussels for the EU. And so we both three decided that what we should do is we should try to collaborate. I can bring out lots of dramatic text, obviously. Joao has a PhD in psychology, which would give some kind of guidance to the program to start with. Natalie could figure out communication rebranding and how human beings communicate. And the idea was to pull these three things together to, start off the process. 2020, of course, derailed us completely, like it derailed a lot of things. But luckily, Natalie was in France. Joao was just finishing his PhD. Now we are in 2021. Natalie is in Lisbon, along with me. And Joao is just finished his PhD. So we are actually probably better equipped at this point to start the process. So we're in the process of first thinking about it and then trying to start off the process. That's the general idea.
But the process sounds really challenging. So which skills did you gain during your academic work that you now can use for your own business?
So machine learning, for example, is something I work with in academia, which is fine because it's just so interestingly. So since I did mention that part of some of the most advanced physics of black holes has to do with the way numbers have patterns, some pattern recognition amongst numbers. The best pattern recognitions of the planet are machine learning processes, machine learning codes. So there is a whole trend towards using machine learning algorithms to understand black holes and things about black holes and so on. It's a very nascent trend. It's not yet fully developed, but there's a trend. So yes, I'm exploring machine learning anyway there. And one of the things I've always been fascinated with is using. I basically work a lot in drama with Samuel Beckett and Pinter. I've done a lot of plays of these people, and these people perform a microscopy. They're like surgeons. They perform precise surgery on the English language. They take a word, like a simple word like hello, and then literally look at it, tear it apart, try to figure out how many ways can you say hello and mean 15 different things, because you can say hello in 15 different ways. So it looks like surgical precision, like there's an equation. It is precisely suited, the analysis of language is precisely suited for machine learning. So I was thinking about this a long time ago, about just doing this in theater. But then when I started talking to Natalie and Joao, I began to realize that we were all faced with the same problem, namely human beings have a lot of narratives, and somehow there is a trend, maybe a local trend, I don't know, to sometimes take convenient narratives that can lead you to unethical behavior, put it mildly, like the one I'm talking about. Why is it that we as human beings have this susceptibility somehow to unethical behavior? This needs a person who understands a lot of stories, more than a human being can, for example. Somebody who can look at the entire gamut of stories we have told through the centuries and then recognize certain patterns, universal patterns. So that's how we got it. So I bring in So machine learning skills are things I do in academia. Okay,
Mm-hmm.
Joao does behavioral economics and psychology. He plays, he's an expert in zero-sum games, non-zero-sum games and stuff. Natalie does just practical communication psychology, which really helps. So it's three of them. We're kind of put
Really,
together.
really interesting. So now, Suresh, one of my last questions. What are your plans with your startup for your future?
Okay, so in the immediate, so three kinds of plans. The local plan is the following. I want to test this process. So one of them would be to actually, at the moment, three of us decided that one way to actually test this process is to take a client on, take an organization, and in this case, I thought we would take an NGO, in fact, maybe an NGO that fights for climate change, and then help them with crafting a narrative. Literally. That means what we will do is we will read all their messages. We'll read all their entire history of narrativizations that they have in terms of climate change, for example, and we will give them back after we run through an algorithmic process, certain suggestions to improve the narrative and see if that really changes behavior or that makes an effect. If that works, and we plan to do this year, this fall actually, if that works, then we have their recommendation. I mean, we have a client testimonial first, and then we start off from there, because it's always good to test our own process to start this process. Once we have done that, then we can basically pitch our project to, venture capitalists and so on and so forth, and then get it up and running. But the overall goal, at least for three of us right now, was to try to see if there are narratives involving, say, environmental damage, for example, which don't seem to be effective. I mean, it is really interesting, right? I mean, there's one thing to say, we are sitting around on a cliff edge and we're about to fall down, and we're still wandering around drinking coffee and tea and saying, well, I'm sure it'll be before we die. It'll be okay. Somehow we have this ostrich mentality. It is amazing. And we would like to see if we can, using our expertise in narratives, maybe try to sculpt a narrative that can really do what narratives do best, impel action in the right way at the end of the day. That was the overall goal. It's very ambitious, of course, so we want to start small and then to try to test the process this year.
That sounds so interesting. I wish you best luck for this. My questions are done. Is there anything left to say by your side, Suresh?
Okay, let me see. I do have something left to say. Well, I've got something left to say, but let me try saying one thing at the end of the day. One of the things that I thought was really interesting about when I first started thinking about this whole problem, I thought what would be interesting was to study human drama, and stuff like that. And we slowly began to realize something very funny. I started looking for stories about the environment that I could give a machine to read, for example. Okay? So, and I found out that we don't actually tell stories about the environment. We just don't. We tell stories about human beings a lot. We tell stories about ducks and rats and mice, Mickey Mouse and everybody else. But we don't really tell stories about the environment. It doesn't really happen very often. Then I began to ask myself, okay, fine. How would you actually convince a small child, that's what a machine is, so to say, that environment matters? And I had this problem, because I had this theory that if you just look at all the human stories that have been told through history, you might understand human beings. That is not strictly true in this case. We don't tell many stories about the environment, actually. And there is a reason for it, I think. We have always thought of ourselves, human beings, as different from animals, different from everybody else. So we have stories about ourselves all the time, okay? It's intensely self-absorbed. And then there are people who study Earth, the outside world, the psyche. These are like scientists, maybe, they study things that are not human, so to say. And for the first time now, the environmental crisis does something very interesting. It's a problem. It's a problem that is posed by the outside world, the physical world, but which apparently depends upon our actions. It does not happen before. Things that we do apparently only affect other people. Our entire legal system is based on, if I do something that hurts you, then of course I get penalized. But if I do something that hurts, a stone or a blade of grass, there is no law that says I should be penalized. We don't work like this. We have this very weird cross narrative here. And that's why we have a problem. So I'm beginning to realize that one of the challenges I think that we face in the environmental battle, so to say, is we need to craft a narrative that explains why climate actually affects human behavior. Why gentle climates, for example, can actually change your behavior and make you gentle, maybe. Or maybe it makes you more easygoing. Who knows? Why sunny climates can actually make you more tolerant, while gray climates can make you depressed. These are things that we know, but we don't have stories about them very much at the end of the day. This is an opportunity for me to try to understand and make those stories happen. Craft new stories. That was your plan.
That sounds so really so interesting. I'm really thankful for your time, Suresh Nampuri. I wish you a
Thank
great
you.
evening and thank you that you
Right.
told us
Thank you
your
very much.
story. Goodbye.
Goodbye.